Good. Yeah. All right. Welcome to the eighth installment, or the eighth amp repair, or however you want to look at it. Um, Tonight I'm going to be doing Klipsch RPW-10. It's an amp that I had on my shelf. Trying to clean up a little space, and I've had some requests for certain things on this amp, so this is a really good example. It's got a lot of problems. We'll go through it step by step. I'm going to try and get through the whole repair tonight. Hopefully I'll have enough parts to complete it and I won't have to order anything. I apologize for slacking a little bit in the beginning of the year. Just have a lot going on. I've been busy and haven't had a whole lot of time. I tried to make a Sunfire repair and I ran out of parts and I had some interruptions, so I'll get back to that. That'll probably be posted this weekend or early next week. Let's get right into this. And remember, if you like these videos, check me out in the Klipsch forums or the Carver site, and like and subscribe to these videos. All right, here we go. So this was a trade-in. It's one of the services that I offer on eBay. I try to always keep an amp in stock and sell a good one. So I'll send a good one out and somebody sends me their burned up amp back, and I kind of perpetuates the cycle. But this thing has a ton of issues. So the cap on the secondary supply is bulged and leaking. It's kind of hard to see on the camera, but it's definitely bulged out, so we have some problems there. The PDC control board is crispy with black glue, so we'll get into that. All of these surface mount transistors, let's zoom in. Zoom on in. Come on, camera, be nice to me. There we go. All these surface mount transistors here, which is actually the power supply for the dashboard, are burnt. This one you can see it's got a little hole in the top of it. That's what, Z2 or 3? Z2. This resistor here, which it's part of a power supply. I don't remember which one, but this is burnt. We have some burning over in the amp area. Some of the resistors over here we're going to have to check. Doesn't show up as good in camera as it does to the eye, but this guy right here is burnt. That guy there. So there might be some problems in here, and we have some gnarly burned glue on the bias adjustment pots. So I'll actually try and get through a bias adjustment. And if it is, I don't know if the outputs are good or bad. I assume, since I don't see any soot on the bottom, that the outputs are good. So we should be okay there. But even if it is biased properly, I'll take it out of bias and I'll show everybody what that looks like on a scope, because I've had a lot of requests for that. So I'll show you how to fix it if it's wrong, or how to make it wrong and then fix it. This amp is extremely similar to the Sub 10. This board here is identical. If you have the what is this, ET35 or 39, or if you have the vertical transformer, it's a Sub 10. If you have the square one that's laying flat, it's a Sub 12. I'm not sure if there is an RPW-12. I never really looked, to be honest, but if it has this style transformer, these amp plates are interchangeable. So let's zoom back out a little bit and get into it. I didn't check the input board, so yeah, this one has a factory rework on it. That's kind of interesting. There's two little diodes just kind of sticking off the top of these caps and glued there. Let's get a little more light. Oh, there we go. Hard to see, but they're there. I don't know why they did that, but they must have had some reason. Generally, I leave these boards alone on the sub 10s and 12s. The caps are usually just smothered in glue, and it's just not worth the time to dig them out. It's not a failure point. I mean, they will age after time, but these are actually decent caps. They're forever caps, so um, you know, it's not absolute junk like the June Foos and all the other, you know, weird brand caps that you see in these. I don't know which brand. I'm trying to see what brand this guy uses here. This one actually does have a decent cap. I'm still going to recap it though, but it does have forever caps. So at some point, somebody said, hey, maybe we should, you know, upgrade our caps a little bit, and they started putting a little bit higher quality caps in. Inrush, current limiter right here, ICL. We want to check that, make sure there's no holes in it. And let's check the fuse. Fuse is almost always blown. Sometimes you get lucky, sometimes you don't. This might not even have a fuse in it. No, it has a fuse, and the fuse is not blown. How many amps? 2. Somebody actually didn't put a 30 amp fuse in there. So, yeah, if your subwoofer amp is failing and it's blowing fuses, and you go out and you buy 2 amp fuses like it says to put in there, and you power it up and it blows the fuse, like, your next decision should not be to go out and get a 10 amp fuse or a 5 amp fuse or anything larger than 2 amps to put in there. If you want to go with a slow blow, fine, go with a 2 amp slow blow, but the second you put a 5 amp fuse in there or larger fuse in there is when you start really destroying the board. So keep that in mind. I mean, people are going to do it anyways, but I recommend against it because it makes more work for me when you send me your board. So I'm going to start just by taking the power supply off the plate. And remember these things have locking tabs on them too. I sometimes forget. You got to push the little tab in before you can pull the connectors off. And you want them to be tight. Loose power connectors and loose speaker connectors don't pass current very well. They do pass a lot of heat though, because when you have a bad connection, you increase the heat at the connector. You have a lot of current flowing through a little area, so make sure your connectors are tight. If you need to, pinch them with a pair of pliers just to smush them down a little bit so they bite on there a little better. That will not hurt anything. So we'll get this off. I'm guessing it would power on, but I really don't want to risk blowing up any more than I have to. I'm sure it would be fun to watch, but it's 11:50 p.m. already, so I don't want to be here till 4 a.m. I'll do my best to finish this tonight, but if I run out of coffee or I get too tired, I'm going to finish it tomorrow. I will do the transistor modification on this. That's a request also that I've been given. And that's Q5, that's by the dashboard. I upgrade that from a surface mount to a T092 package. And so far I've had pretty good luck with it, so the secret's just using epoxy. There's really nothing fancy about it. I'll have to find my diagram so I can show everybody how to put it in. But as long as you're halfway decent with soldering, you can do it. And I'll show you how to remove the part. There's a million wrong ways to remove Q5, and there's one correct way. I will show you the correct way. And anybody that comments that says, oh, you can just remove that with hot air, go ahead and try it. I would love to watch you do that. Alright, here we go. We've got to break the glue off. Sometimes it needs a little persuasion. Try not to cut your fingers, it hurts. We'll set the plate aside for now. We'll come back to the plate later. Step one is going to be to contain this junk. Normally I have cotton balls. Cotton balls really take this thermal stuff off really well. Paper towels work too. They just kind of smear it around a little bit. Cotton balls just suck it right up. But I want to get as much of it off as I can because I hate this stuff. I absolutely hate it. It gets everywhere and it doesn't come off. Alright. So, dashboard's got to come out. This guy is definitely corroded. I don't know if it's bad yet. I doubt that our FETs are shorted. If our FETs were shorted, usually the fuse is blown. Actually, always the fuse is blown, but we'll check them anyways. We'll just do a quick continuity check on them. So if you get a temporary short like that, it's not really a short. It's just the nature of how the device is functioning. See, that doesn't mean it's bad. You know, as soon as you let off that leg and touch it again, the short clears, and that's actually the was that the gate lead? Yeah, you're actually on the gate lead, so you're actually gating the device on and off with the voltage that's coming out of your probe. So just be careful with that. If you use an analog meter, I don't really know how that would affect it, but you know, you're better off measuring ohms than you are just doing a continuity check. But I'm used to it and I know what I'm looking for, so usually I can get away with that. I'm quite surprised that the board just seems to be thrashed in certain spots, but in others it's okay. It's kind of weird to me. I'm really hoping the dashboard's okay. I'm actually going to pull these out and test them. That's the best way to do it. And I want to get all that glue out behind this cap here, so pulling the boards just makes sense. If you don't have the luxury of actually testing your boards, I would recommend pulling them, putting a socket in where they are. Get your board, you know, tested, get it up and running, and then remove the socket and put them in. You don't want to keep putting these boards in and out because you're just going to wreck the board. I don't really have a better way to do that. I guess you could maybe put them into a breadboard and run jumper wires off the breadboard into this board if you wanted to, if you didn't want to socket it. Yeah, I don't really have a good way to test these aside from removing them out of the circuit and putting them into a known good unit. I thought about like designing a test fixture for them, but the amount of work that it's, you know, it would take to make something like that, and you know, nobody's ever going to build that to test their board. You know, everybody's just going to kind of do the trial and error type thing. So I kind of lost interest in that idea, and I just took an old amp apart, the one that I had laying around, and turned it into like my little dummy test fixture. And it works quite well, so you'll see that in a little bit. Let's get heated up on the solder sucker and start tearing this thing down. I think I mentioned this in every video, but if you don't have one of these, don't do these repairs. It's a Weller DXV80. I'm not a huge, you know, Weller fan per se. I do like this station, and I like some of their soldering stations too. Um, but I also like Hakko, or Hakko, or whatever you want to call them. I've used their small soldering station since I started doing this, and I refuse to upgrade or change from it because it works and I like it. I started with a FP-101, which was like one of the first. Um, it was like right before the digital ones came out, but it had like temperature controls on it that weren't like a knob that you had to twist. And I've used that for years, and then I bought an FM202 because I wanted to use tweezers and the solder sucker from them. But the solder sucker that I bought requires an air supply, and I don't have air at my workbench, so I cannot use it. And I'm not spending $1,000 to buy a Hakko station that has a vacuum pump in it. Won't do it. I might make one day. I might take or find a replacement pump for the Weller and make my own solder, like hybrid solder sucker, but for now, I really don't need to do that. It's about 20 degrees outside right now, and the air is like ridiculously dry, so my throat is drying out on me. So I apologize for muting and binge drinking coffee. Alright, we're almost up to temp. Alright, we're at temp. Step one, always step one is make sure you put lead on these pins. Get your leaded solder and be generous with it and just blob it in there. Doesn't matter how neat it is, doesn't matter if you bridge pins. Just throw a big blob of lead on there. And actually, I'm using my thin stuff right now, but you should be using a thicker solder because it contains more flux. The whole reason for that is to dilute the lead-free solder. If you're trying to suck lead-free solder out of these, it's just a pain. So what I like to do is I get in here and I just wiggle the board with my finger. And then I get the hot air on the other side, heat it up, and keep wiggling. I'm not pushing hard, I'm just giving it a little wiggle. What that wiggle's doing is it's preventing anything that's remaining in the through holes from locking them pins back in place. I had a dentist that used a similar technique when he was like numbing you up or drilling for cavities. He would like yank on your lip and kind of distract you so you wouldn't bite them. But kind of same principle. You just want to, distract the solder so it doesn't harden up inside the through. The through holes are too small for the pins is basically what it is. And some board layout guy thought it would be a wonderful idea, like, hey, let's make this as small as possible so it just barely fits. But if you do the wiggle method, and you can see it's nice and loose now, I can just kind of gently wiggle and pull the board out. And I didn't take any of the traces or through holes with it. So this is a garbage board. Like, these boards are the cheapest made boards that you can imagine. They're like Chinese made, just junk boards. But I desoldered it, and I didn't ruin it. So, we'll have a look at this. It's very common for all your resistors to be brown on here. And let's zoom back in. Oh, wrong way. So you can see how, the resistors are are not bluish in color anymore. They're like a greenish, brownish. You know, these boards do run a little hot, but they parallel the resistors on them, so that they should, you know, be able to handle the wattage that's passing through them. And we can just run a test. Now, one thing I found on these is there are different versions of this board. It'll say 660038. Of course, camera's not cooperating. But it'll say 660038RA. But there are multiple revisions of this same board with the same number on it. You might have one that says like Rev 3 somewhere on it. There might be blue in color. But they're all the same, with the exception of a couple parts. And I believe it is this capacitor and these two resistors that are next to it. And that's the difference between like a sub 10 or a sub 12. I have that info on the Klipsch forums. I don't have it memorized, but I actually stumbled upon it, and I didn't realize that until, you know, after repairing a bunch of amps, and somebody actually was posting on there that their board was different than what I have been using, and I never thought to check it. There was no indicator on there. You know, it had the same part number. It didn't say like Rev A, Rev B, or anything like that. So who would have thought? But now we know. And if they had schematics of all this stuff, we would have easily known, but that doesn't exist. So let's see what we got here. Checking ohms. So we have 102K. Let's see what we got here. 102K does sound like a weird number to me. $394 ohms, that sounds good. Let me actually pull up. I'm going to pull up the forum page so I can kind of follow along and provide you with some good info instead of garbage info. I just need to find my parts list or my schematic. So okay, so the top two, they should be 200Ks in parallel for this board. And that's 102.8, that's close enough. Then we should have 392 ohm. 392.5, that's pretty good. And then this guy is showing 550 ohm, which I believe is 1100 in parallel. I will double check that, because that's this guy and the next guy. And this guy and the next guy. Should be 390. It's measuring 378 in circuit. We'll still call that close enough. And you can see on the back of the board which devices are in parallel. And you can also see that this has a nice chunk of nasty glue on it. So if you're reading we'll just go through this real quick. So I'm going to read these two, and it's going to show a proper value when I pierce it. Alright, so we're at 550 ohms. Now I'm going to read these two, and we're at 520 ohms. I'd be willing to bet that when I clean all this nasty glue off, that value is going to change. Now, it doesn't always happen, but this stuff looks like it's on the verge of becoming conductive, and I am going to guess that it's changing that value. Like, I haven't gone through this board. I don't know what the status of it is, so it might be affecting it, it might not. but I will say that this is absolutely nasty and it's got to come off. And you got to get around all the pins, all the legs. Dental picks are your friend here. Just get in here and just scrape it out, clean it off as good as you can. I scrape them and clean them, and then I hit them with a wire brush. And I hit them hard with the wire brush. I don't, I don't just go over them lightly. I want all the glue off the board. If you expose the copper on the traces, that's fine. Exposed copper that's not touching can't short itself out. Nasty glue that is turned conductive can. So clean out under the legs. If you really want to be crazy, you can take the parts out, but there's really no need for that. You just want to get down to shiny green circuit board. It takes a little messing around. It takes some time. Just get in there and clean it up. And you don't want to cut through the traces. Don't push that hard, but just hard enough to get it clean. I'm going to take a wire brush, which I do not have in my box. I gotta go get my wire. Actually, I'm just gonna go off camera for a second and wire brush this. Alright, so I hit it with the brass brush. These are just cheap Amazon brushes, but they're really high bristle count, so I really like these brushes. I haven't been able to source anything nice like this locally. And I'm just looking to make sure that, I got all the junk out, and right in here, there's still a little bit more stuff, so I'm gonna just hit it again. I have been known to sandblast these boards. That is effective. I don't use sand though. I actually use just cooking baking soda. It's very, very mildly abrasive, but it does wonders for taking off like nasty stuff like glue and solder masks. So if you have a little handheld sandblaster, or media blaster, I guess I should say, you can use that with cooking baking soda. Alright, so this guy is clean. We'll set it aside. Next, we're going to go on to the main board part. I'm going to turn off my solder sucker because this guy's coming out next. I like to clean the tops of the caps off. I don't cut into them, but I do just kind of lightly scrape, just to get as much of the gross glue off as I can. Like, I don't know, you have an amp that's refurbished and looks somewhat nice, and then you just have gnarly looking glue on some of your parts. It just doesn't look that good. That's a personal preference. I mean, you're never going to get it all off. You'll actually damage the caps trying to get it all off, but it doesn't hurt to go that one little extra step to try and make it look a little nicer. I'm actually going to clean off my mat here so I don't get that junk all over everything. The carbonized glue. paintbrush handy too. Like, this is just like a little trim brush, and I've used it, you know, a zillion times, so now it's retired, and now it's like my cleaning brush for this kind of stuff. Works good. Not good for paint anymore, but it works great for cleaning parts. Right, next is our main cap. Now these caps should be drained. It's been sitting on the shelf for a long time, but we'll hit it anyways just to make sure. And it is. And we'll hit this guy over here. And you know, drain your caps. Don't put yourself at risk if you don't have to, especially if you just took this out of an amp. It's not worth any unnecessary risk for 2 seconds of discharge. So, alright, I gotta change my tip. This unfortunately needs a large tip to pull that out. This guy's still hot, by the way. Don't touch it with your fingers. You can touch the tip, but don't touch the actual iron with your fingers. You'll be screaming. And it hurts. I burnt my wrist right there. Right in the tender spot, right on the skin there where it flexes. That hurts. Definitely take your voltage regulators and fold them down. Get them away from your caps. If you want to put a heat sink on them, that's great. I don't know why they didn't do it from the factory, but get them away from your caps. That will cook your caps. This guy's 100 volts. You can upgrade this cap if you want to. I generally put a 100 volt cap back in it if that's what it had, but you can go to 160 volts if you want. And I think I even have some. There's the 100 volt. But you can see I believe this is 1,000. I better double check. So that's 470. So you can, if it'll fit, you can go to 160 volt 470. You can also use 200 volt if it'll fit, or you can just use the original 100 volt. And if you use a quality cap, usually you're not going to have any problems. And there's a little bit of headroom on these. I'll measure that, and it's probably going to be like around 90 some volts, but I'll probably replace it with 100 volt. That's what was in there. And I'm not going to be upgrading this amp or, keep it factory. If I was going to use it for some weird application or, some high demand application, I might, invest the time to upgrade it. But if I'm just doing a restoration, I'm going to keep it the same as it was. As long as you use a high quality part, you're not going to really have problems. We'll check the voltage though, just to make sure we're not exceeding the rating. If we're exceeding the rating, then we have to upgrade. So removing these caps is a pain. The only successful way I've found to do it is you got to thoroughly clear the through holes. I mean, really get anything you can out of those through holes. And then you got to get a little mean with it. Take your favorite pair of pliers. Well, this one came out easy. I didn't have to fight it, but these things usually put up a pretty good fight. So sometimes you really got to grab them, crush them, and rip them off the board. This glue's already pretty brittle. If this glue was still rubbery, That cap would not have came out that easy. So this is 470 microfarad. Let's see how good it still is. So main cap still good. We could reuse it, put it back in. We're not. We're going to put it in the garbage. Alright, I need to make sure I have a replacement for that though. 200 volt snap in. There we go. The new one's going to be a little bit bigger, a little bit better. There's a couple different diameters that the Klipsch amps use, and I don't know if I have all of them. They have the larger ones that are leaded, but they also have a snap-in that has the same diameter. Then they have the skinnier diameter. Oh, here. Oh, I don't know what I have in my box, so I'm just kind of digging through here, wasting everybody's time. There we go. There's one of the larger ones. It's a little bit shorter, but a little bit larger in diameter. So different amps use different diameters. These are both the LGU series, just different sizes, and they're both 200 volt, 470 microfarad. So equivalent parts, just different size cans. And some amps they'll fit, some amps they won't. I believe that the shorter one, yeah, the shorter one would fit in there. It'll fit just fine. But I don't have a lot of the short ones. I have a lot of the tall ones, so I'm putting the tall ones in there, which is also fine. They all have 10mm spacing on them. And it should snap right in if I could line it up properly. There we go. So yeah, no problem at all. We'll put a little silicone blob in there to hold it in place, and everybody will be happy. But first we got to get the glue out. We're going to try to scrape first. And I'm just going to go with a flat chisel tip X-Acto blade that's been sharpened probably 50 times. And just start working it out. See what I can get out that comes out easy. Now, like you can see over here, this stuff is still kind of rubbery. And it's not going to come out easy. We got to use heat for that. You know, the stuff that will peel and pop out by itself, go ahead and get. If it's not coming out easy, don't fight it, because what you're going to do is you're going to jam down in and you're going to cut part of a trace off the board. Don't do it. Get your heat. And my temperature is 120 C. My air is going to be a medium flow. You don't want to blow this stuff all over the place. You don't want to get it too hot either. If you get it too hot, it releases some pretty nasty fumes. And I don't know what they are, so definitely not good for you. Let's see if I can give everybody a view. It's hard to do and stay out of the camera, but you want to get some heat on it. And just heat that glue up, and while you heat it, it will scrape out. If you don't have a hot air station, you could probably use a blow dryer. If you don't have that, I don't know. I don't know what you'd do. I guess a heat gun, like standard heat gun for like removing paint, would probably work. But just, you know, kind of lightly give it a scrape. Then it comes off pretty good. Don't worry about in between traces. Leave it there. If there's a little bit of residue down on the board and it's buried in between some traces, it's not going to hurt nothing. What is going to hurt is you trying to scrape it out from the traces. In the back of the caps, you know, you don't have to be too crazy about that either. Just give it a little You know, a little bit of cleanup, but don't go nuts. We don't want to damage the caps. The film caps generally don't go bad on these models. I don't actually think I've ever seen them go bad. But you don't want to hit them with too much heat because then they will go bad. Clean up the goo. Clean up all the dust and nastiness on the board. And we are ready to throw our main cap back in. You can see on, I left the glue in between these two right here. Well, it's not really touching anything on the board that's going to cause any problems. If you wanted to, you could, probably pop it out from in between the two. We'll do that here just as an example. But you just gotta be careful. You don't want to create more unnecessary work for yourself. Especially if it really isn't, terribly relevant to the operation. But just so we can say we did it. There we go. Clean it off. Take one of your little brushes, brush it off, dust it off. Alright. Glue's gone. Now, before I put the cap back in, I want to address these parts here. We might have to cheat and get the light down in there. That doesn't really seem to help, does it? But there's two transistors down there and a Zener diode. Those, let me remove the dashboard. Maybe that'll give us a little bit better view down in there. Let's do that next. In order to do that, we have to remove the heatsink from the MOSFETs. So there's usually some kind of melted plastic on there or glue. What I find works best is just kind of break the seal with the screw a little bit and then take your X-Acto knife and kind of work it around one of the edges, and that stuff should just snap right off like that. Just be careful, don't stab your fingers. Try not to scratch the aluminum too much. These will be covered in thermal paste. So make sure you have like a little bin or a napkin or something to set them on so you don't get it all over the place. Now if you have a screw head that's completely full of this glue or whatever it is, and you can't get a screwdriver in there, don't force the screwdriver in there. Put some heat on it from the heat gun or whatever heat source you have, and it softens up and gets kind of melty, and then you can just take your screwdriver and just push it right into the screw head and grab that screw. Don't screw, you strip those screws out and you're going to have a bad day. So try not to do that. I like to clean the excessive amount of thermal paste off of these. One, because I don't want it all over my bench, and two, because I don't want it all over my fingers. I mean, you're not going to get them spotless, but the big blobs you can get off, and I don't know, a little bit of film on my mat is easier to clean than huge blobs that get everywhere and on my coffee cup and on me. So, I don't know. I spend a little extra time cleaning them because I really hate this stuff. And there's more than enough on here. You can see it's just blobbed on there so thick. So I'll just respread that out in a nice thin layer, and the devices will still have adequate thermal pasting. Alright, we're going to change back to a small tip. And we will pull out the dashboard. Sometimes you got to change this tip out while the iron's hot. The solder will harden in the end. That doesn't always happen, but sometimes it does. So we're about a quarter of the way through disassembly. While we're waiting for that to heat up, let's measure R51. And I don't remember what that's supposed to be off the top of my head. I want to say it's 10 ohms. Helps if we're not in capacitance mode. So it helps if you read the right resistor too. I believe our 51 and 52 are both 10 ohms, but either way, this one that has the burn on the outside of it is reading 13 megs. And I wish I could zoom in a little closer. Tell you what, let's go to my face cam here. Let me see if I can get this up in there so you can see what that looks like when it's extra crispy. And this thing probably won't focus either, but come on, camera, stop looking at me. I can't get it to focus. Let me see if I can open up my Logitech app. This is the price you pay for being cheap and using webcams, but I'm not trying to do production quality here, so you'll have to bear with me and my hacks. Focus, there we go. Aha, success. Sorry that took so long, but alright, so you can see this guy right here. And you can see that it's burnt. So, anytime you have a burnt resistor like that, like there's the good one. Good one's down here. Bad one's right there. So, you know, measure your resistors if they're looking burnt. Magically, my other camera focused too. Look at that. Maybe I need to go mess with that more often. So yeah, we know that R51 is bad. I'm pretty sure that that is 10 ohms. I'll have to look at my notes or at my spare resistor bin, because I think I have a few of those. And I believe that is a 3/4 watt. 22. I'm going to be so upset if I don't have one of those. Let's see what we got here. Can't read my label because it got messed up in the bin. $1.1K. I don't think that's a 1.1K. I believe that's 10 ohm. I might have to steal one of those off of a parts board. I should have new ones, but I do not see a 10 ohm in there. Oh, 10 ohm. Here we go. 10 ohm, 1 watt. So I have two different ones. I have a real big one, and I have some smaller flame-proof ones. I'll use the smaller flame-proof ones. I believe those are made by Dale. But either way, good resistors. And it doesn't hurt to go a little bit higher in the wattage rating than what they originally had, because clearly this guy gets a little hot. So, alright, we're heated back up. Let's take the dashboard out. And the same process that we used on the PDC board. And somebody asked me why I call this PDC. It's got PDC written in the corner on there. And I don't know what that stands for, like power dynamic control. That sounds good. And I call this the bash board because right on the board right there is where it says bash. And bash is the trade name of these amps, and it's made by the Indigo company, which is, I believe, a Canadian company that sold out to Sonovox. So, Indigo is no more. But I still think they make the 300S, which is available on Parts Express, which is what a lot of people buy to fix, all these speakers. And I will say that the last time I checked, the power supply on the 300S is the same as these power supplies. It might have the sub 12 transformer on it though. I'd have to look. But same footprint for the power board. Should be the same square or same non-square board, L-shaped board. So I let it up these pins, and now I'm wiggling and solder sucking. Trying to remove this board any other way without a solder sucker, and you might as well throw your amp in the trash. Unless you want to do point-to-point wiring, or you have through-hole repair kits. This is, in my opinion, the only way to do this. I've tried those soldering irons that have the little suction ball on the back of them. Didn't work. I've tried the little pen thingies where you hit the button and it's like spring-loaded. That didn't work. You need something that can source some heat. It has longer than a quarter of a second of suction. And I mean, I don't even, that'll fall out. That's how you want to take those boards out. I hate doing through-hole repairs. It sucks. So these guys here, and I don't think I can get in any further on the zoom. Yeah, a little bit. Alright. Oh, yeah, we can go way in. Come on, camera. Be nice to me. So we have Z2, Q5, and Q6. Q5 is usually the failure point. Q6 generally doesn't go bad. Now, because this capacitor looks like it was about to explode, I'm guessing that, there was another issue going on. Also, it looks like there was some glue on the dashboard. Didn't appear to be getting charred yet, but underneath the dashboard, you got to check for the glue, because what happens is when they squirt this stuff in here, it does go under and touch some of these pins, and then some of these on top, and it will short it out. This one is in pretty good condition. I'm surprised. So I'm just gonna get a, give it a little brush with the wire brush just to get some of that residue off, and that's clean enough. That's clean. Nothing's gonna short out with that. So we'll pull this cap out. These things are kind of hard to remove too. I don't know why they didn't use snap-in or why they didn't use a larger through hole. I have frequently damaged these. There's a couple ways you can go about repairing it. One is you just scrape off some of the solder mask and just bend the lead over and solder it onto the solder mask. Same with this guy. This guy actually connects over here. So that's one thing you can do. Or you can just leave it raised off the base and raised off the base of the board so it sits up a little higher and solder both sides. There's a few different ways you can repair it. Or you could do a through-hole repair. Generally, I do the through-hole repair because it's a more professional-looking repair. But I have done all three other methods. Or two, or however many there were. Try your best to clear these holes. And you kind of just gotta hope you got it, because if there's glue all around the cap, you can't get any air underneath the cap, so it won't be able to suck any air through the through holes to clear the solder. So you just gotta kind of hope that you got it, and then you gotta hope you don't run into that where the cap is ruptured and leaking juice and just destroying your board. That's a bad cap. So I'm going to scrape some of this stuff off. And that's actually the solder mask on the board just deteriorating. Because the the pin's still in there. It desoldered, but it left the pin in. That top part of that through hole is thrashed. So, yeah, fun stuff. We'll clean it off. I'm not going to go too crazy with it yet. I just want to get the electrolyte off. And you can see this cap is going bad for a while. Here's the leg from the cap. Not in the best shape. So yeah, this cap is destroyed. Pretty cool, huh? You can tell by the bulge on the top that it's bad, but once you pull it, and this is why I recommend recapping these amps, because you never know what's going on underneath. Sometimes you can't see it. I was working on a Sunfire, and one of the last caps I removed actually had the same problem. It started leaking around one of the legs, and one of the legs stopped making connections. So just pull them out. You're not, you're only talking a couple bucks for some caps. It's not going to make or break the repair by changing them out. If you're doing this, you should have a little bit of budget to do it the right way. Sourcing parts, is not too hard. Don't buy your parts on Amazon, though. I can't tell you how many people buy parts on Amazon and, try to do a repair with them. If you buy capacitors on eBay and Amazon, 99% of the time they're either going to be fake, as in not the manufacturer you think they are, or they're just garbage. Like just cheap bottom of the barrel caps. Use good high quality parts. And try not to deviate from what the parts actually are. Like capacitors, you can always go up in voltage, no problem. And resistors, you can always go up in wattage. But when you start getting into like MOSFETs and things like that, like just stick to what they are unless you really know what you're doing and you really understand how to read a data sheet and make a decision that the part you are using is a valid replacement. Otherwise, you're just going to make more work for yourself. Now, I'm really not worried about saving these caps, so I don't care if I get too much heat by them, but I am going to be careful by this other little Zener diode. Don't rip any of the traces off. We're just cleaning out the glue. And you want to get it all on this top side. Dental picks are your friend. Now, over here by the switch and the inductor and the filter capacitor, that you can leave a little bit of the glue. You want to get it off the diode and anywhere where it's touching other components. So get it off the capacitor legs, off the diode. But you can leave a little bit of the glue on there, securing these larger parts together. That generally is not a room or not a area where you have problems. Again, don't get your caps too hot. Just try and, work around them. Get a little bit of heat in there and then kind of use some mechanical force to clean them out. Takes a little bit of playing around. You gotta, get used to your tools and your heat and how you're using it, and it helps if you don't have, the other large caps and things in the way. These guys, bend them out of the way if you need to, if they're in your way. They're coming out, so diodes and ceramic caps and resistors are generally pretty heat tolerant, so we can just continue to pump the heat down on this glue area down here to get it good and soft, so hopefully it comes out a little easier. You don't want to break the legs of the capacitors off, but you want to get the glue out from under them, so just under the leg of the diode, get it as best you can. Again, that's not a real common failure point, but if you can get the glue out, get it out. You could lift the part if you really want to. I'm not going to do it, but if you really want to get in there and get as much as you can, pull the part off. Clean it. Get in there and get it out. Get in there with some tweezers. It ain't gonna hurt nothing. Just gonna take some more time. Just don't get the cap too hot. If you scratch your board up a little bit, no big deal. At least not in this area. So I'm just working to get the rest of it off this diode leg. It's fighting me a little bit because it's wrapped around the leg and it's a tight space, but if you work it, you'll get it. Just take your time. Dental picks are your preferred weapon of choice in this area. Try not to give too much into your obsessive compulsiveness. But if you have like one little piece of goo down in there that's fighting you, get it out and move on. And that's what I have right now. There's like one little piece of glue that I loosened that won't come out, and there it is. Alright, so now we got the glue out. Most of the glue. While I have this hot, I'm going to take the glue off the pots, but we have to be careful here. You don't want to melt the nylon on top of these pots. So I'm going to try as best I can to use mechanical force first to get as much of this off as I can. And if yours are still soft and the glue is still yellow, you're going to have a harder time getting it off. But you don't want to damage your bias pots. So remove the glue. Don't damage your pots. And I mean, they could be replaced. It's not the end of the world, but if you don't have them in stock or sitting on the shelf, guess what? Now you got to order more parts. So mine are pretty crispy, so the glue's coming off kind of nice. So I'm going to hang up the hot air, and you'll notice I turned them, so the bias adjustments are going to be off now. which is kind of good because I wanted to go over how to adjust those anyways. But you know, do as best you can to get them clean. Doesn't have to be perfect, but just get, you know, the majority of the glue off. Scraping them lightly is probably the best way if the glue is dry. And I would say that that is probably adequate. Make sure they're not connected. You know, make sure they're clean in between. Don't scrape too hard on the top of the pots. I gotta clean my mat again. It's looking pretty gnarly. I'm gonna pause for a little mat cleanup here. I need to pause for a whole bench cleanup is what I need to do. This bench is atrocious right now. Alright, that's better. Back to it. So now we got to deal with the damage that's caused by the leaking cap. I'm just going to take a tiny little scraper and I'm going to scrape that as best I can. If you take the solder mask off, that's okay. But I want to get as much of the gnarliness, nasty, you know, whatever. Well, I know what that was. It's electrolyte, but we want to get as much of it off as we can, as well as any of the additional glue residue that's left. So just, you know, take your time and clean it. And you'll see the copper starting to come through as I remove the mask. That's okay. That's fine. Clean it off frequently so we can see where you're working. Now, I'm going to keep cleaning this. I'm actually going to go to my fiber pen. This is just a fiberglass scraping pen, but I'm going to do this whole area, and I'll show you why. You can probably see why as I'm doing it. But it's taking the corrosion off of this copper. Clean the pad on the other side. I want to get it good and clean, because the cleaner it is, the better I'm going to be able to understand what's going on. And you can see just that little bit of brushing has really made a significant difference. And I can keep going, but what I really wanted to see is the connections to the pads. Let's zoom back in. Let's have a coffee sip. So I'm looking, so right here is the negative connection, and that is just the pad, and the pad's still good, and it appears to be isolated from this top plane over here. So we'll check that with the meter, but that one appears to be good. But if I look over here and I look at this, I see the substrate of the board, I see copper here, and then I see in this little square area here missing copper. So when this was arcing underneath that cap, it started eating away at the copper plane. I wonder if a magnifying glass would work on this. I've never tried this before. Oh, this is going to work. This is awesome. I never even thought to do this. Boom. There you go. So you can see all around this area here, and it's backwards in the camera so I can't, but we're missing copper all around in here. Like, the through hole's good. You have just a tiny little bit of copper here still left, and then this is all missing. So we got to rebuild this on the top side so we get a good connection. Now you can see that the top side does connect. Let me get my meter out. We'll just have continuity so you can hear the beep. I don't need it in the screen. So we're going to check this plane. Alright, plane is good. Also connects to this leg of the diode. That's good. Now we're going to check the other side of the cap. No continuity, we're good. No shorts there. So there's a couple different things you can do. So we're looking at the positive pad, which is this guy here. Now the leg of the diode is right here, and we need to get those connected together. So right now they're not connected. What you can do is you can rebuild the through hole. That's one way to do it. Put a new through hole in there. If you don't have a through hole repair kit, what you do is you just scrape off the solder mask in this area, and you already have a break in the planes. So you have isolation on the planes. Just take this leg, just fold it over and solder it to where you scraped that mask off. Or you can just take that leg and run it over to here and solder it to this pin here. But I don't recommend doing it that way. I would scrape off the solder mask right here, bend the leg, and get a good solder right to that plane. Or if you wanted to, you could scrape off the mask heading over to this leg here and solder it that way. Either is acceptable. I'm going to do it the harder way. And actually, no. You know what? I'm going to do it the easy way today. I'll do exactly what I'm telling you to do. I think if you've watched my previous videos, you've seen me do a through hole repair. It's you know, not that fancy. I am going to repair this through hole though. Anyways, but I'll repair the through hole so I can get a solder joint there. You know what? We could do both. No, we'll take the easy way for once. We'll be all right. We'll just fold the leg and solder it that way, because we're going to secure these with silicone anyway, so it's not going to matter. I'll drill it. I'll put a through hole in just to get a good solder joint going through the board, but I'm not going to rebuild the copper on the top. It's not necessary to do, because we have that same plane right here on the bottom. If we didn't have this plane on the bottom and it didn't connect to that leg of the diode there, then we would have to rebuild it on the top. But I'll just talk through what I do. So I redo the through hole, and I put the factory end on the top on this side here, and then I take trace repair kits, and I'll lay out trace repair pieces where the copper is missing on the plane, and then I just solder over the whole thing to rebuild the plane and the through hole in one shot. It makes for a nice repair, but on this board it's just not necessary. So if you have damage like this where the board has actually been eaten into by electrolyte, I would take the easier way out. You know, if you don't you don't have to even repair the through hole. I'm just doing it because I have through hole repairs, and you know, it doesn't hurt to show that again because I have the stuff on hand. But we're gonna do it the other way that I recommend. So you get to see a little of both. I'm just not gonna rebuild the pad because it's really not necessary, and nobody's gonna see it anyways because it's underneath the cap. And I'm actually going to shine up this copper a little bit more too. Just where the outline corrosion was. I just want to get as much of that off as possible. I'm pretty sure it's dried up by now and not active, but if I'm going to be OCD, I'll be OCD about that. Get the electrolyte off your copper. Electrolyte's conductive, you know, think of it like salt water. Salt water conducts electricity better than regular water, so the body needs electrolytes because the body conducts electricity too. Alright, it ain't going to be perfect because the copper is damaged. Get it good. Don't, you know, burn through it trying to clean it off. That's why I like the fiber scratch pens. They don't really do excessive amounts of damage. And we will use this little best kit that I have. And I'm not sponsored or anything by these guys, but they do make a damn good product. It's expensive. There's nothing cheap about any of these. I think I figured out after like shipping and time and, you know, everything involved, it's like $3 to replace each one of these. Something like that. I know it was like something kind of ridiculous. Normally I would use my calipers to make sure that I'm using the right drill bit. That is one thing I'll tell them. When they sell those tubes, they should have a little holder on the side of the tube that also holds the drill bit that goes with them, because it's a pain when you have a thing like this that's full of drill bits and you don't know which one goes with which through hole. It drives me nuts. So we're going to drill out whatever remains of the old one, which wasn't much because we did not have continuity. Clean the board. And throw the through hole in there. Factory side on the top. And the reason we're doing factory side on the top is because I want the flare to be on the bottom, because it'll stick up a little bit. And granted, these caps have some room on the bottom. There's indentations, but still, I want the flare to be on the bottom and out of the way of the cap. So set the little anvil up. And I need my amp stand. I'm going to get it all dirty with nastiness. Alright, so I'm just going to take the little punch, and this is one of them snappy punches. You push it down and it snaps. I don't like to snap it. I just like to work it. Put it in there and wobble it around, and I don't flatten it out. I leave a little V on the bottom of the cup so it sticks up off the board. That way I can get solder underneath there. Makes a better connection. Or it gives the solder like more place to to wick into. And for a through-hole board, that's not like, you know, a computer motherboard or something that's like super critical about stuff like that. It's a perfectly acceptable thing to do. Now I am going to bend the one leg this way, so we're going to follow that, and we're going to scrape off some of the mask. So I'm going to take my little chisel scraper, and I'll leave the kickstand in here just to make it a little easier to work on. And this doesn't have to be pretty. I mean, just start removing solder mask. And you don't have to remove a lot of it. I mean, you can if you want to. You can go the full length of the leg on the capacitor, but you don't have to do that. But what you do have to do is the path where that is going to be, make sure it's clean and clear. So that's the size I'm going to go with. I'm not going to connect it to the leg of the diode because there's really no reason for it. I am going to polish it though with my little scratch pen, nice and shiny. Clean my board. And now we're ready. So you can see the top. Let's try that little zoom in trick again. I have some different lenses. I don't know if that... So you can see the new through hole. It's in place. This lens is kind of dirty and scratched. So is this one, but there's our new through hole. You can see around it there's no copper, but that's okay. Now, if the copper wasn't all eaten away, that would be a really nice connection. But for what we're doing, don't matter. And nothing else around here is going to get replaced, so I'm going to put the cap in now. Make sure we check our polarity. Negative goes with the little negative symbol right here. Or negative goes towards the transformer if you want to remember it that way. So I'm going to solder the good through hole in first with my iron that is not on or hot. Use a good size tip when you're doing something like this too. You want to get heat onto that board. So let's fire this up. So we're just going to solder one leg in. And we're going to do that to position our cap. And remember, this through hole was good, so you know, it should wick down in there and hold this guy in place. If you feel like it's not, throw some flux on there. Shouldn't really be necessary, but if you want to, you know, flux it and let it really flow down into that hole. All right, then I'm gonna take like a, you know, my punch or something. I'm just gonna fold this leg down and fold it down as flat as I can get it. You might crush your new through hole a little bit if you replaced it. Doesn't matter. And then give it a snip. Try not to send metal flying across your work area to where you don't know where it's going to go, like that one just did. And let's solder it in place. So I'm using my thicker solder. and I'm using that because it has a little more flux in it. For something like this, you know, you can use a little bit of flux. That ain't gonna hurt nothing, because you do want to get some heat in there. You want this thing to stick, and this large copper plane will suck the heat out very quickly, and it will dissipate. So I'm going to solder the through hole too. Solder that. And to be honest, it wouldn't even, you know, it would be okay to hit this with a larger iron too, to make sure you really got a good flow and connection. But that's going to be fine. So I'm going to trim this leg. We're going to leave it a little bit taller. Not too tall, but just a little bit, so, you know, we don't take down anything from that fillet. And then we'll check for shorts. No shorts. Again, that's something else that's switching on there. But we have a connection between the diode and the cap is not shorted. Perfectly acceptable repair. Focus. There we go. That ain't going anywhere. Especially when we'll put a blob of silicone in there. It'll be happy. That is probably the one area where I will say that it is acceptable to not do a complete through-hole repair on it. You get a better connection, and I just don't think the time and effort is worth rebuilding that copper plane. You don't really gain anything from it, so why waste the time? Alright, now we are going to do the Zener diode. Z2, well here, let's have a look at these too, now that I know we can do this. Let me see if I can shine this lens up a little bit. Turn off my iron so I don't start a fire. So Z2, yeah, you can kind of see the burn mark on it. It's there. I don't know how big I can get, but it's burnt. That one, that's Q5. That one's burnt. And Q6 is also burnt. It's very uncommon for these to have, you know, issues like that. I don't know, you know, what will cause that. Like I'm just looking in here to see what's going on. Z2 is definitely toasted. The Q5 and 6 look like they got hot. I don't know if they actually failed, but Q5's got to come off anyways. Let's just check and see what's going on with Q6 and 5. Q5 appears to be shorted. Let's check R55. R55 is showing 9 ohms. I don't think R55 is 9 ohms. Yeah, R55 is 475. So I'm not going to change that resistor until I remove Q5. I think Q5 is the cause for that resistor reading low, and we have to remove Q5 anyways to do the T092 upgrade. And I've had some requests to see that, so you're going to see it right now. Here's how you remove an SOT 23 package from a Klipsch amplifier board. Chisel tip razor blade, top leg, slow rock, little pressure, snip, bottom 2 legs, slow rock, little pressure, snip. Nope, it's not fully cut yet. It usually comes off a heck of a lot easier than that. This one's fighting me. That's because the device is like cracked. There we go. That's how you remove it. You cut the legs. Do not try and remove it with heat. I'll say it again. Do not try to remove it with heat. If you throw a hot air thing on there, you might as well just kiss your pads goodbye. You're going to rip them right off. And these traces are a pain to rebuild, and they're tiny. And just don't do it. Take my advice. I'm giving you the best advice right now on how to do this. If you want to put me out of business, this is how you do it. And I know somebody's saying, but this is just a hobby for you. Yeah, you're right. That's why I said that. Because you can't put me out of business because I'm not in business. Alright, so after I cut that off, I heat the pads up, put some solder balls on the pads. So let's use our fancy microscope. Zoom in. I'll try and do this whole thing zoomed in. I know my head's going to be in the way, but just bear with me as I get through it. But that's what you want. Three solder balls on Q5. 1, 2, and 3. And notice we didn't lift any of the tracers or pads up. We just removed the existing legs and added some lead to it. Take a little ISO. Clean that area off a little bit. Again, be kind of careful because Q-tips can rip pads off too. Not so much when you have solder balls on them, but be careful. And just because this thing's in such bad shape and Q6 looks like it's toasted too, I'm going to replace Q6. But first, let's check our resistance for R55. I'm going to guess that R55 is good now. So there we go. 4750. 4.7K. And if we look at that guy, it should say 4751. Resistor is not bad. Transistor was bad. It's usually Q5. Q5 is usually the problem in this area of the board. let's take out Z2. Z2 is definitely bad. It has a hole in it. I've seen that happen a few times. It's one of the more uncommon failures, but I have seen it before. Q6 is the least common failure. They come off so nice when you cut them. I got a rat's nest of wires here. I need to free up my soldering iron. Hold on, please. Please hold while I melt the wires going to my headphones and microphone. Alright, we will take off the legs of Z2. Now this one, on Z2, I'm actually going to clean the pads, because Z2 is going to remain a surface mounted device. Only Q5 gets the honors of being upgraded. So I will throw some flux down on here now, because I don't have the good solder wick that has flux in it. Chemtronics makes really good solder wick with flux. I use it at work. This is Radio Shack made in Taiwan soldering braid, but you know what? It works pretty good, and I got it dirt cheap. And we lost a pad. But luckily we lost the pad that is not connected to anything, so we're still in business. But that is literally how easy it is to tear pads off on these boards. I'm not gonna replace that pad because it doesn't connect to anything. But you know, just a second of heat and that pad is gone. Let's see if I can show it. It looks like something connects there, but it really doesn't. Wait, that's Q5. Wrong spot. There we go. And it looks like that larger trace continues to go there, but it doesn't. It stops and then it loops around and goes through up to the top. So we're still good. But that is, you know, a perfect example of how annoying these boards are to work on. You know, you try to remove everything properly, and you just get a little bit of heat on these really sensitive pads, and they freak out and they just lift right off the board. Alright, Q6 is next. And I'm actually out of Q-tips, so I might have to go run upstairs and grab Q-tips. Strangely enough, my wife is still awake too. She's usually never awake at this hour. She's probably going to come and yell at me for staying up too late. Alright, Q5 was bad. As I cut the two bottom legs off, the device cracked in half. So, same thing, cut the top off. Just try and be careful, you know, minimal amount of disruption or damage to the board. And I don't think the electrolyte got over to this side of the board. It's possible. But, you know, we can heat these up. Usually if they have traces going to them, the pads won't lift. It's possible, but usually not. Or if they do, the traces lift with the pads, but they still remain attached, so you can just kind of fold them down. And my way to reattach them is I use super glue. Super glue seems to work pretty well for traces and pads that have lifted off of fiberglass. So I'm going to continue cleaning off these pads. And like I said, I'm being careful. I'm trying to do the minimal amount of damage. So far we have been kind of lucky. Clean it real good with some ISO. And then we can begin the rebuilding process. And now I gotta find these parts and remember what they are. I used to have them labeled Q5 and Q6, and I don't anymore. So I need to find these parts. So bear with me because I'm still not used to where everything goes. These are surface mount. Wait a minute. I think I have them in my box. I think one of them is labeled a 2X, but I kind of got away from using the nomenclature on them. I am going to have to look it up because I don't remember what they are, and I moved those parts. So I need to find Z2, and I know Z2 is a Zener diode, but I don't remember what it is. I think it's that guy. I gotta pull up my notes. You gotta bear with me here for a minute. Let's see if my computer will cooperate. While I'm waiting on that, I will show you what I do for Q5. So here's my little Q5 cheat sheet. And my computer is telling me access is denied to my files. Wonderful. So here's my cheat sheet for going for surface mount to a T092. And I will show you how I do that as soon as I get these surface mount parts on here. And my server is being a pain. Bear with me while I log in. Transferred everything off of my desktop and I started putting it on my NAS server because I don't want to lose it. And I recently just changed all the login credentials for everything, and that's why I was having trouble logging in. Alright, so Z2 is an MMBZ5243. So that is a device that has the label 8T on the top of it. 8T. MMBZ 5243. And it's a 13 volt, 225 milliwatt Zener diode. That is Z2. So we'll grab one of those and we will put it on. Now, I don't use hot air for this part either. Let's put my diodes away. And really the 8T and A6 are the only diodes that Klipsch uses for surface mount stuff anyways. So to get these attached, I am going to go to a fine tip on my soldering iron. I'm going to go to my fine solder. And I'm just going to pick a pad. And put a solder ball on there. Then I'm going to take my device and I'm going to solder it in place carefully. With that solder ball. And I'm a little like OCD about this. I want the devices to be perfect on the pads like they were from the factory. I mean, you don't have to be that crazy, but that's how I do it. So we're going to get Z2 on there. Now remember, we're missing a pad on there, but there's nothing we can do about that. Get a good connection. And actually it helps these devices to have nice solder balls on the legs instead of just that, because it helps dissipate the heat a little bit. So you're not hurting anything by putting too much on there. Q5 and Q6 are MMBT 4401s. And that's going to be 2X on the markings. And an MMBT 4401 is also the same as a 2N 4401. So you will see what happens next. So I'm going to just verify that this guy says 2X on it. And you're not going to be able to see it because I can barely see it. I can't even see it in the packaging. Just to make sure I didn't goof up and put the wrong part in my little baggies here. And it does. It says 2X. I don't think you guys. Yeah, there's no way you'll be able to. Oh wait, maybe you can. I mean, it's really hard to read unless the light catches it at the right angle. Well, take my word for it. It says 2X on the top of it. 2X. There you go. You can kind of see it. 2X. So I'm going to solder this one where Q6 is. So same thing. I'm just going to pick a pad, put a solder ball on it, and then put this device onto that solder ball. And I'll show you what this looks like when it's soldered in place. If you can get in there, you know, use your fingernail. Don't burn yourself. Use your fingernail. Push it down onto the pads. You know, you want the device laying flat onto the board. Once you have one leg tacked down and it's lined up, the rest are easy. You're just soldering them at that point. And a micro soldering iron really would help here. And I'm debating getting one, but I don't do that much micro stuff, so this has suited me thus far. Alright, let's see if I can show you what that looks like now. So Q6 is in. Q5 not in yet. Z2 is in. And that missing pad on the back is not going to hurt it. Like I said, once we get everything in, there'll be some epoxy on there, and that's going to hold that in place. So we don't really have to worry about it. Q6 isn't going anywhere. So now we are well on our way to getting this repair in motion here. I'm going to double check our 51 just to make sure that's 10 ohms, and I'm pretty sure it is. That's part of the power supply that feeds this for the dashboard. It's just got that resistor and one diode, and it comes off of a winding on the transformer. I just got to find where it is. I think that's with power supply notes. Yes. So that is an auxiliary power supply, and it's one winding on the transformer. It goes through D7, which is a 100-volt diode. There's two caps on there, which this is the cap for that circuit, the filter cap, and R51, which is a 0.6 of a watt, 1%, 10 ohm resistor. And I forgot what it was when we measured it, but it was not 10 ohms. I think it was like 10 million, 13 million. Not 10 ohms. 13 million and counting. 14 million. Bad. Bad, bad, bad. Alright. Next. What time is it? It's 1:30. I'm going to call it quits at 2, so let's see how much we get done. I'm not going to put these boards in yet. Let's do the recap. Do the recap and the resistor removal next. Fire up the solder sucker. While that's heating up, let's look at our resistors down here and hope they're not cooked, because I don't have these. 510 ohms, that sounds right. 510. Transistors and diodes look to be alright. I think it just got a little hot over here. The 510s seem to have been affected by the heat. These two, oops, you guys can't see what I'm doing here. Sorry about that. There's two resistors down here. There's this guy. And it just looks a little brown. Looks a little brown to me. I don't know. It's not really showing up on the camera, but looked like it got a little hot. And there's one over here on the top side of the board too. They're just like brownish in color around them. The camera doesn't really pick it up. It looks fine in the camera, but it looks brown there. But they're measuring okay, so I think we're going to be alright. I'm going to check the transistors that are next to them. Make sure they're not shorted. Just do a quick check with ohms. If they're shorted, you know they're going to read shorted. I think we're good. I think we're going to be good on the output side, so that's comforting. We might actually get this thing fired up tonight. So these caps are not fun. They have bent leads on them, and I don't want to do any through-hole repairs. So we are going to do the snipping method. Cut the cap off, and we're going to do one at a time. Or we can cut them all and stack them up in order. I'll do that. I'll just cut them, and we can zoom out for this, for cap replacement. So I'm going to just cut the caps off, all these caps, and I'm just going to line them up in order here on my little cap tray. And I don't really need to do that because I kind of know what they are, because it goes 47, 100, 47, 100, and it alternates. But just for the sake of being consistent with how you should be doing your repair, I will pull them off and sort them. Some of these are going to be hard to get to, but snipping leads is always preferred to tearing out through holes. I can't think of any scenario where snipping leads would be worse than having to do a through hole. You know, do whatever you got to do to try and get them out of the way, and you know, get your snips down in there. We're going to do the bipolars as well. All the caps are getting replaced. Oops, that's our last one. This is our second to last one. I believe they're the same value anyways, it doesn't matter. And we got one more, this guy here. And there's what looks to be a burn resistor underneath him, so we're going to check that guy too. Alright, all our caps are out. Let's see what we got here. Another 500, that one's actually 511 ohm. Or no, that's 5.1K, sorry. That's reading 1923. I'm not going to rule that as bad yet because it's still in circuit and it's in series with another resistor. Let's see what he reads. Yeah, so I'm getting a false reading on that. It should be 5.1K. If I pulled it out of circuit, it's probably going to read 5.1K, so I'm just going to leave it alone for now. I never liked how these had the leads. They bend over and around and down. I wish they would have just went straight up and down. It's a personal thing. It doesn't really matter. I do try to straighten them out a little bit. I'm usually not successful. But just try and keep them away from... These get warm. Keep them away from your adjustment pots and keep them away from your cap air. You should be alright. Now the fun part. Removing the cap leads. And this actually really isn't bad at all now that we've snipped them. Magnetic tweezers, comes right out. Effortless. Make sure you put a little bit of solder on there, a little bit of lead. Remember, your kids are not going to be eating these amps, so Lead solder is perfectly acceptable to use. If you're chewing on amplifier boards, you have more problems to worry about than lead. This is the preferred way to recap this board. With little to no damage on these through holes. Reworking these through holes sucks. I've done it. I think I've done it even in a video. It's not fun to do. And even taking the caps off this way, you do have some risk of lifting a pad, but it's generally minimized compared to trying to desolder them. Let's see, I got one here and 2 filter caps and we're done. You can definitely see there's advantages to using the leaded solder too. It stays liquid longer, you get a cleaner joint. It's less prone to fatigue and cracking. I mean, we're putting it inside of a subwoofer. That's a pretty abusive environment. I mean, these things are vibrating for their job. So a little bit of resilient solder isn't a bad thing. If anything, like, it assures you that where you performed your repair is not going to be the failure point if it does fail. Alright. Caps are out, new caps will go in. We'll do them all at once. So now that our small parts in here are done, I'm still going to leave the main out. I'm going to put the main cap in last. But we'll do the little ones. You know, check the board. This one still has a little bit of glue by this one leg. We'll get that glue out of there. Just a tiny little bit by that through hole. Sorry about your ears if I just blew your eardrums out by blowing on that. I sometimes forget. There is another Zener in there. I'm going to check that guy just to make sure he's good. Appears to be okay. Oh, we got to pull our resistor out. Got to pull out our 10 watt. So same thing with him. I'm going to get in there and I'm just going to cut the top leg on one side. Come in there. Cut it on the other side. And we'll remove our toasted little resistor. What happened is Q5 probably shorted out, started drawing excessive current through that resistor burned, and then everything else went out of whack. I'm not sure when the large cap on the secondary went. That would have been a separate isolated issue, or it could have been failing for a while. It's hard to tell. Alright, we're making decent time here, so we'll just work our way backwards. We'll pick our cap. This is a 47 at 50 volts. We'll pop him in there. Double check, make sure we got the right value, throw it in the garbage. Check the polarities, negative is facing towards this side of the board. It's marked. And these have square and round pads. Square pads are positive on these boards. Not on every board, but on these boards. Make sure when you solder the caps in too that you get solder flowing all the way through the pads. Now, there's two methods of thought on this, and I don't think there is a right or wrong answer. Some of these boards come with 35 volt, 100 microfarad caps. Some of them come with 25. I generally put back what was in there because I don't have the data that shows why and when it was changed. You could go to 35 volts for all your 100 microfarad caps. It's not going to hurt nothing. But these are for the voltage regulators. For the plus minus 15 volts, and I don't think they see 25 volts. So we can look at it. I'm not sure. We'll do that at the end of the video. We'll check our voltages to make sure we're in range. This should be 47 and 50. And it is. Just make sure you're putting the caps in with the right polarity. If you do that, you'll be in good shape. But yeah, when we fire this up, I will measure the voltages on these caps because I'm curious to see how close to the edge they are, and I'm sure they're probably pretty close. That's probably why they eventually got upgraded, but close is okay. Exceeding, not okay. So if these read 23 volts and they're rated for 25, probably going to be alright. The supply should regulate and never let it get up that high. I've never found an instance outside of some other failure that caused it that caused one of these to rupture or leak. The big cap, yes. These little ones, no. Where'd this guy come from? 47. 125. 47. 125. Last one should be a 47. It's 125 volts. No, it's 47 and 50. Forty-seven hundred, 47, 100, 47. If you do install one of these caps backwards, make sure that you replace it. Don't flip it around. Replace it. After you power this thing on and the cap's been put in backwards, there's an extremely good chance that you have caused irreversible damage and you're doing yourself no good by just flipping it around. We're using high quality caps here. These are Tier 1 UPS series Nichicons, rated at 105C for, I believe, 2,000 hours. The forever caps that are in these are pretty good. Could I have left them in? Probably. Forevers are pretty decent caps. I don't know where they are on the tier list, but they're pretty good. Did I just goof here? Not paying attention? $4,700, $4,700, $4,700. No, we're good. We're good. C41. I'll double check just to make sure I didn't goof, but that is by the plus minus 15 volt supply. Little sanity check never hurt nobody. Where are the VREGs? VREGs are somewhere in my notes. Not quite sure why they didn't use switching regulators on that part of the supply. It's not my design, so I can't really, say anything about that. Oh, I think I just saw it. Nope, that's the main power supply. Bash power supply. There we go, voltage regs. C41. And C41 is not part of the voltage regs. Where's C41 at? C42. C41. C41 is part of the on-off circuit. Oh, so yeah, that brings up a good point. If your auto on-off feature is not working, this is the cap you want to replace. C41. It's a terrible system. Don't use the automatic on-off ever. Unplug your subwoofer. Use the on-off switch. If you don't have an on-off switch, put it on an on-off switch. But this is the cap that does the automatic shut-off. And what it does is it just mutes the outputs. So you have an audio signal coming into this amplifier section. The auto on-off, all it does is it just pulls the audio signal to ground. That's your standby mode. So think about that when you're doing something with this amp. If you just leave it in auto on-off, chances are you're killing your amp. And if you got your amp back from me and you leave it in auto on-off, I will know. I'm not going to tell you how I'll know, but I will know. 4.735 volts bipolar, and I believe both of these are the same for, 4.7 bipolar. These are in the audio path. 4.735 bipolar. 2 new caps. Alright, so that wasn't too bad. Full recap. Didn't take too much time. Probably would have been faster if I, was actually paying attention to what I was doing instead of trying to talk my way through it, but how would anybody else learn? I find visual aids are the best way to learn something. Figuring it out on your own is kind of cool too, but sometimes you can't do that all the time. So hopefully this will help some people out. I know a lot of the how-to videos on various things have helped me, so this is my way of like giving back to the how-to community. And hopefully making some of the people that do repairs upset, because a lot of those guys overcharge. If a repair costs more than a replacement amplifier, the repairs are a little too expensive in my opinion. So just double checking this is a 10 ohm fireproof. And you always want to use flame-proof resistors in power supply areas where they actually do dissipate current and get hot. I'm sorry, where they pass current and where they get hot. Because I mean they could flame up. I mean I've seen it. I've seen them damage boards. These ones probably not so much, but you know, it doesn't really cost more than a couple pennies to get a flame proof over wire wound or you know, metal film. So, and some of those even come with flame proof coatings. Just be smart about how you're gonna choose your parts. Think about where it goes in the circuit, what's going on. Try to understand how your amp's working. Don't just go and blindly replace parts on it. You don't learn anything by doing that. You know, check the circuit out, try to figure out what's going on. Anybody can just replace all the parts on a board and fix something. It takes the fun out of it. If you understand how it works, it helps you understand how to repair it. And I'll be honest, I don't understand how this entire amp works yet. But when I run into a new problem, I try to figure it out. And hopefully prevent it from happening again. So this board will get all cleaned up. I'll clean all the flux residues off. You can see on the bottom we had some heat issues over here, which kind of corresponds to these resistors on the top of the board that get hot. They do get hot. This part of the board does get hot, especially if something's not working properly. Let's check our outputs really quick, see if we have any blown outputs. Again, I'm just going to use continuity and look for shorts. And I'm just going right across the pins of the outputs. So no shorts, so that's good. So the next step is going to be to set this aside. And we are going to test our boards. And I'll show you the easiest way to test them in circuit. I'm just going to test them on my tester because I don't want to solder them in if they're bad again. I will be right back. So here's my tester. And you can see that it looks pretty familiar to the one we're working on. sub 10 RPW-10, sub 12 RPW-12. Same board. A little bit different circuitry on these guys and different values for caps and such, but other than that, same board. So this is my tester board. I did not recap it. I did not clean the nasty glue off of it. It works, and that's really all I need. I socketed the board so I can pop pieces in and out that I want to check. I'm going to do one at a time here, so we'll start with the PDC. If the PDC board is not working, generally it's this guy right here. And let's zoom in and I'll show you. Because I know somebody asked about a PDC rebuild. I'm not going to get into a rebuild, but it's this guy right there. That little, it's either going to be black or blue. That is called a diac, and it is a DB6. You're welcome. So I'm plugging the board into my tester. Actually, I'm just plugging it into an amp. This would generally be the same thing as soldering it in. And I'm going to get some power. And we're going to go current limited. Just so we don't let out too much smoke if something's bad. Check to make sure our power is off. Our power is off. Whoever invented safety outlets is a jerk. They always break. Alright, we got our power connected up. Now, we're current limited, and I know these connections are close together, and I'm trying to separate them. But even if I do get a dead short right there, when I'm hooked into the current limited supply, all it's going to do is light up my light bulb. I'm not going to have sparks flying and shooting into my face. I'm not going to blow a breaker. I'm not going to do any damage or any harm. All I'm going to do is turn on a light bulb. So, it's good to do testing with a current limited supply. For safety reasons, I would recommend it. So let's get the meter back in. We're going to go into voltage, DC. And I'm just going to take my probes and stick them right into the two voltage regulators. Just let them sit in there and just let them touch the voltage regulators. And I'm going to make sure my board's plugged in. And we're only checking PDC right now. So I'm going to turn the power on, current limited. See what we get. 24 volts. That means I have the probes backwards, so this one's positive, that one's negative. But I have 24 volts going across my regulators. That tells me that everything from here over is working. So I know that I have a good power supply and everything is functioning how it is intended to function. Power's off right now. Before we go on to the next step, we're going to discharge. So carefully flip the board over. We're going to discharge main. And we're going to discharge secondary. Alright, we're discharged. Now I'm going to take out my tester dashboard. And I'm going to put this one in. Now you'll notice that this one is an RB. For the RPW-10, the code for that is RB. I haven't figured out what that means yet, but there are different components on the board to control the secondary supply based on what position that is in. And I'm working on getting that all documented. I have to find each one of these boards so I can document what the differences are. Make sure you plug this board in the right direction. Don't plug it in backwards. So what we're going to do is we're going to flip the supply on. We're going to check to see if these two resistors get hot. And the easiest way to do it is just to carefully just touch them with your finger after you flip the switch on. So we're going to flip it on and just check, and we're not getting hot. So that's good. So now I'm going to shut off. Then I'm going to get my probes ready. And I don't remember which is which, but we're going to flip on. We're going to carefully, don't touch anything else on there, just get your probes in there, and we're going to look at the two legs of these resistors. We have 5 volts. See that? 5 volts. Polarity doesn't matter for positive or negative 5. So if we have 5 volts, we know our dashboard is good. If we don't have 5 volts coming out of there, or if these things are getting hot, something is wrong on the dashboard, or something is wrong with the repair you did down on the power supply. That is how I test my components. And you can do it in a tester board, or you can do it in a board, in your board that you're working on. I prefer to do it in a tester board because if I have to rework them, it's easier to just pull it out and do it. If you're not comfortable sticking your scope probes or your meter probes down in there, get little grabbers. Like I have these little clippy grabber things that go on the end of my probes, and you can just reach in there and hook them on and just let your probes dangle. They also have little grabbers with wires on them. I mean, there's a lot of different things you can get. So make sure our power's off. We're going to unplug. And discharge. Discharge main. And discharge secondary. And I have these going into a 200 watt light bulb that's underneath my desk in a fixture, so it does a very good job of discharging caps. And I haven't found a cap yet that could kill that, so. Alright, put my known good boards back in. And I will put my tester board out of the way. Alright, so we are now in home stretch. We have Q5 remaining, and I'll do Q5 with the dashboard out just so everybody can see a little better. This is how I do the upgrade. N4401, which is the same. Let me just double check. Yeah, so MMBT 4401 is the same as the 2N4401, just different package. So here's how I do it. If we're looking at the board and I'm looking at my diagram, collector is going that way, and then you have base at the bottom and emitter at the top. So collector on one of these guys is this leg right here. So that leg's going to go to that pin at the top. The base is the middle, so the base is going to go down. So I hold the transistor like this, with the flat side facing my finger, and the round side pinching with my thumb, and I'm just going to pull that one leg towards me a little bit. And basically, all I'm going to do is just simulate the footprint of an SOT23 with a T0220. That's going to be hard to see. You can kind of see it. So when I put this device in, the flat side's going to face the dashboard. I'm going to do the collector first, then I'll tack down the base, and then I'll tack down the emitter, one leg at a time, on top of the pads where Q5 originally was. And I already have the solder balls on there, so it doesn't matter which one you solder first or second or third, and actually, you know what? I'm going to make it even easier on myself. I'm going to clear off the two lower pads. So I'm just going to leave the one solder ball at the top. That way I can get it pushed down real nice onto that pad. Now you got to be careful though. When you solder this in there, you don't want to bump it because you'll just rip the pads right off the board. It takes a little precision. You got to kind of watch what you're doing. It doesn't have to be absolutely perfect. I'm giving myself a little bit more light, and I'll try and zoom in on this when I get it in there. But take like a pair of tweezers and just kind of bend the legs while supporting the. You have to support the device. You can't just bend the legs without holding onto the device. But you want to get them so they're over the pads, as close to the center of the pads as you can get them. And then tack them down. And once you get two down, the device starts to get fairly stable. It looks a little crooked right now, but I think it's touching the pad. Looks like it is anyways. You just gotta take your time and you gotta be careful. It's the only thing I can say. Once you get, the two legs down, go back to your first one and actually solder that one in, and then you should be good. You can put a decent little solder ball down there, get a good fillet on it. Get it in, but that is how you do the Q5 upgrade without, having to do point to point or anything else ridiculous on there. And if you don't like it, you can hit it with a little flux on one of the, like this one's got a blob running up the leg. Put a dab of flux on there, heat it up, let it flow back down. Flow it back down to the pad. And then get in there with your magnifying glass and look at it. Make sure you have good connections. All those look pretty good to me. You really want to have a sanity check, go on your meter and make sure you're getting connections to the pins where they go. Like this guy goes to that resistor. This leg goes to the other side of that resistor. Top leg goes to the board. So I know I'm good. I know I'm in there good. and I have a decent connection. So now I'm going to clean the flux off the board. Carefully. I'm just getting kind of in between there. I'm not putting a ton of pressure on it. I'm just trying to get the grime and the flux off. That's all I'm doing. A longer bristle brush would be better because you can actually get in there and wipe it a little easier without worrying about like knocking the device over. But the problem is the surface mount devices are just a little bit underpowered. Q6 can seem to survive it. Q5 seems to have a limited life. Every board that I've worked on that has not had the factory Q5 upgrade, Q5 just looks burnt and tired. So do as best you can to get the flux off there. As much flux off as you can. And the reason we want to get the flux off and clean this board real good is because we're going to epoxy those legs and that pad into place. So that's clean good enough for me. Dashboard's going to go in next. We already tested it. We know it's good. So we're going to carefully put him in. We're not going to disrupt the transistor that we just put in. And if you break the pads and the traces off, you can rebuild that area. It's just a lot of extra messing around, and it's not worth it. So just be careful and mount it on the top side, and you'll be much better off with the repair like that. That's how I do it. You can do, if you want to do it differently, you can do that your way, but I would highly recommend upgrading Q5, and I would highly recommend putting it on the top side of the board. Now I also made a replacement circuit board, and if you tear the traces off or the traces are too far damaged to rebuild, I made a board called a piggyback. I don't know if I have any of them handy. Let's see. I don't. But I made a board called a piggyback, and it actually solders onto the back of the dashboard. And it has this entire circuit here. It's got that Zener diode. It's got the 2N4401 Q6 and R55, R57, and C26 all on that board. And if this area just gets totally destroyed and it just can't be rebuilt or fixed, I just glue that board to the back of this board, and then I run a jumper over to the power feed, a little jumper wire, and I can get it back up and running even if that's completely damaged. So not all is lost. Even if you do completely damage the board, it can still be repaired. Before I put the dashboard back in, I'm going to check the gate drive resistors. These should be okay, but I like to check them anyways. They should be 100 ohms or 220 ohms, and I'm reading 220. And 220. So everything is checked out good so far, so I think we are going to be in good shape. PDC board's going back in. I will solder that in place, and we will be ready to power test this. So since it is so late, what I am going to do is I'll go through the power testing, confirm that this board is working, and then tomorrow I will make a video on adjusting the bias and the actual test. So I'll just make that its own separate video, and then anybody that wants to watch that can find that information without having to watch this whole video. I think that's the better way to do it. Plus it'll save me some time because it's already almost 2:30 a.m. and I need to get to bed because I have to go to work tomorrow. So that being said, I'll epoxy the transistor in too. So basically what I do is I just mix up some 2-part epoxy, and I just cover all 3 legs of that and just kind of spread it around in that area a little bit down there on the board, and that just keeps that transistor from breaking those pads off. It just reinforces that whole part of the board. And since the legs of the transistor are long, they will act as heat sinks for some of those traces and the other components on there. Not very efficient, but definitely better than a surface mounted part, so it does nothing but help. So let's throw our tall tank cap in, observe polarity, make sure we put that in right. Solder him in. Or solder it in. I guess you can't really assign a gender to a capacitor. Although these days it seems like you can assign a gender to anything you want, so maybe that's not a fair statement either. Alright, main cap soldered in. Same exact test as we did before. Probes into the actually, yeah. So I'm just going to show everybody this just to reiterate the factor of safety. So I'm going to power this on. So these are hot right now, and I'm going to touch them together, and you're going to see probably, well, no, you don't even really see a little spark. Now you can still get shocked from this, and it still could kill you, but if these were just raw power coming out of the wall and you did that, there would be a massive spark. It would burn and ruin your connectors. So this is why it's important to have a current limited supply. You don't have that power coming through, so it's not going to damage anything on your board. If you're doing this kind of stuff, you got to have a current limited supply. A 100-watt light bulb in series with your circuit. So if you have a short circuit, it acts as a switch and it turns on your light bulb, and it doesn't act as a short circuit and fry your amp board. Important thing to have. Alright. Let's see if we got main power. We do. Voltage is a little higher, but that's okay. Checking my resistors, see if they get hot. They are not getting hot and burning me. Let's check our power that's going to our outputs now. We want 5 volts on there. And I'm looking for my little clippy things that actually fit these probes that I have, and they're somewhere in my tech box, and I'm not going to dig them out. So I'm going to just flip on again. We're going to go in here carefully, and we're going to look for 5 volts. And I got 5.3, which is good enough. Both of our supplies are working on this board on both sides. Now I did say that I would check the power that's going to the caps. So I'm going to carefully flip this guy over. Remember, these caps are still charged. Like here, let's just look at this one. It's still at 72 volts. 74 volts. That cap is holding. That'll give you a nice little buzz. Let's flip it on. Current limited still. And let's see what we got on this cap. So it's a 100 volt cap. We're at 91 volts. Yeah, we're kind of close to the threshold, but it's still within tolerance. I think we're fine to leave it at that. I do want to check one of these other ones that's at 25, so we will carefully get in here. And I see 28 volts across that cap. 14 across that one. 28 on that. So the 100 volt caps where I'm seeing 28 volts, I'm actually going to swap out. I'm going to upgrade them because it's exceeding the value of the cap. And let's see what this guy's showing. That guy's showing nothing because that's on the muting circuit. But these two, this one here and this one here, are exceeding the value. So I am going to upgrade those to 35 volts. Let's drain. Drain. And I'm going to do that. Which two was that now? Well, that was a 50. Actually, I don't have to because those are both 50 volt rated. We're good. I thought that was the 100 microfarad caps. The 100 microfarad caps are the lower sections of the supply. So those are rated for 50 volts, and I was reading 28. We're well within tolerance. I can leave them be. So we are good. This amplifier is up and running now, and it is ready to be adjusted and reassembled. I'll go through the bias adjustment in a small video tomorrow. We'll get the scope out, we'll look at the scope, and we'll cover that in just a quick video on how to adjust the BIOS, and that'll just be a video alone by itself. But that is how a full restoration is done on a sub 10, sub 12, or an RPW style amp. You know, there may be some more issues, you know, that you have to do. You might have to replace the FETs. That's pretty common. You might have to repair the dashboard. And I'm sure I'll get to a couple of those that are like that, but I mean, this was a pretty good example of, you know, almost everything that needs to be done to do a restore. So I appreciate, you know, anybody taking the time to watch this and tuning in. You know, let me know in the comments what you want to see me do, what you want to see me work on. If you have questions, I'll try to answer them. It's really hard to do diagnostics, you know, without actually having the board on hand and being able to test it myself. But you know, I'll try to answer any questions that you have and walk you through your own repairs if that's what you're trying to do. So just remember to like and subscribe, follow me on the forums, and hopefully we can continue to make amps work again. And I have plenty more of these restorations to come, so I will see you all soon. Have a good night.